Aim is how can we find the distance between 2 points. So let's first review one of the things we learned about finding the distance of 2 points in a line segment. In other words, I want to find the length of AB without counting the squares from A to B. And one of the things we did in one of our previous lessons is we took the absolute value of the difference between the two numbers. So for example, if I want to find the distance from A to B, I'm interested in the difference between -6 and +4. And so I took the absolute value of -6, I subtracted 4, which is equal to the absolute value of -10, which is equal to +10. Or we could have taken the absolute value of 4 minus a -6, which is equal to the absolute value of +10, which is also equal to 10. Similarly, if I had a vertical line, I wanted to find the length of line segment BC, what I'm doing is I'm trying to find the difference between 9 and 3. So I take the absolute value of 9 minus 3, 9 minus 3, which is equal to the absolute value, let's make that look like a 3. Okay, I take the difference, or the distance of the absolute value of 9 minus 3, which is equal to the absolute value of 6, which is equal to 6, or I can take the absolute value of 3 minus 9, which is equal to the absolute value of -6, which is equal to 6. But suppose I had a diagonal line. The method is exactly the same, but what I'm going to do is I'm going to treat this diagonal line as the hypotenuse of a right triangle. And I'm going to use, because I have a right triangle, the Pythagorean theorem to find the length of AC. What does the Pythagorean theorem say? Well, you learned that in probably 6th or 7th grade. Pythagorean theorem says a squared plus b squared is equal to c squared. In other words, the sum of the squares of the two legs of the triangle is equal to the square of the hypotenuse. Let's call line segment AB lowercase a, we'll call line segment BC lowercase b, and we'll call the hypotenuse c. So one of the things you have to do is determine which point A or point C, are going to be point 1 and 2. For purely arbitrary reasons, I'm going to call point A point 1, I'm going to call C point 2. And the reason I'm doing this is because I want to be able to distinguish between point A's x and y value from point C's x and y value. So A's x value I'm going to call x sub 1. I'm going to use subscripts to refer to -6, and I'm going to use y sub 1 to refer to 3, which is point A's y value. Similarly, I'm going to call 4 x sub 2, because that is point 2's x value, and I'm going to call 9 y sub 2. What we're going to be doing is we're going to be using the Pythagorean theorem to derive the distance formula. So let's see what I'm going to do. I want to find the length of A. We just found the length of A before. We know that line segment AB, which is leg A, is 10. Right? How did we get that? Well, let's get this right triangle back in here. What I did was I took the difference between 4 and -6. So what I did was I took 4 minus a -6. And what I'm going to do is I'm going to use the Pythagorean theorem to actually solve this problem. So I'm now going to square this, because that's what the Pythagorean theorem says to do. And to that I'm going to add the difference between point 2 and point 1's y value. So that's 9 minus 3. And I'm going to square that as well. And that is going to be equal to c squared. So what I've done here is exactly what the Pythagorean theorem says to do when you're looking for the length of the hypotenuse and you have two legs, the length of two legs. So 4 minus a -6 is 4 plus 6, which is 10. So that's 10 squared, plus 9 minus 3, which is 6. That's 6 squared, which is equal to c squared. And 10 squared is 100, and 6 squared is 36, and that is equal to c squared, which means c squared is equal to 136. And in order to solve for c, and we're going to leave our answer rounded to the nearest 10th. What I need to do is take the square root of c squared, And whatever I do to one side, I must do to the other. I take the square root of 136. So c is equal to the square root of 136. So let's get our calculator up here and see what the square root of 136 is, and that is equal to 11.66. So we're rounding to the nearest tenth. So our answer is going to be C is equal to 11.7. Let's take a look at what I did. In order to find the length of AC, I want to find the distance between point A and point C. So what I did is I used the Pythagorean theorem. But let's see if we can refer to each of these numbers here in my calculations using x sub 1 and y sub 1, x sub 2 and y sub 2. So let's see what I did. 4 is the same thing as x sub 2. So I had x sub 2, and what did I do? I subtracted from that what? Minus 6, which is x sub 1. And what did I do? I squared it. That's what the Pythagorean theorem says to do. That's what I did over here. To that, I added 9 minus 3. What is 9? 9 is y sub 2. So I took y sub 2 minus 3, which is y sub 1. Let's make that look like a y. I subtracted y sub 1. And what did I do again? I squared it. That's what the Pythagorean theorem says to do. That's what I did over here. And that is equal to c squared. Now, the interesting thing is, why didn't I take the absolute value? Well, the answer is very simple. When you square a positive or negative number, you're always going to end up with a positive number. So I don't need to take the absolute value of the difference between my x values and the difference between my y values, because when I square this value, I'm going to always end up with a positive value. The next thing I'm going to do is I'm going to turn this c into a d, because d stands for distance. And what I'm trying to do is derive the distance formula. So what do I do now? I'm trying to solve for d, so I need to take the square root of both sides. Well, let's do that. So let's change the color on this. Let's make it red. And what I'm going to do is I'm going to take the square root of d squared, which means I have to do the square root of whatever I have on the left side, because whatever you do to the left side, you must do to the right side as well. So let's see what I've got so far. So I've got the square root of d squared, which is equal to d, equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is the distance formula, and we've just derived it. Right over here is the distance formula. So let's make a note of that. The distance formula is d for distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Let's take an example. And I'm not going to plot these on a coordinate plane. Let's just start applying this formula to this problem. Find the distance between the points minus 3, 4 and 5, 6. First off, let's decide which is going to be point 1, which one is going to be point 2. I'm going to call minus 3, 4 point 1. It's purely arbitrary. I'm going to call 5, 6 point 2. And what I'm going to do is I'm going to use these values to start filling in my distance formula. So d is equal to the square root of x sub 2, which is 5, minus y sub 2, minus x sub 1, which is negative 3, and I'm going to square that, plus, parenthesis, y sub 2, which is 6, minus y sub 1, which is 4. So all I've done is I've substituted my x1 and y1 and x2 and y2 values into my formula. That's all we did. So that is equal to the square root of 5 minus a minus 3 is 5 plus 3, which is equal to 8 squared, plus 6 minus 4, which is 2 squared. Let's make a little more room here. So what do I have? I have the square root of 8 squared, which is 64, plus 2 squared, which is 4. Now, let's take a look at the instructions. The directions tell us, leave your answer in simplest radical form. So, this is equal to the square root of 68. Now, in order to simplify this, I have to look for the largest perfect square that divides 68 evenly, and that number is 4. 4 times 17 is 68. So this is equal to the square root of 4 times 17, which is equal to the square root of 4 times the square root of 17. So my answer is 2 root 17. Why don't you try this problem? Put your computer on pause, put this video on pause, and then when you're done, we'll walk through it together. Okay, so let's see what we need to do. It says find the length of line segment, the line segment whose endpoints are minus 4, 2, and 2, minus 1. The first thing I'm going to do is make more room by clearing the ink. Okay, so distance is equal to, first off, let's decide which one is going to be 0.1, which one is 0.2. Arbitrarily, I'm going to pick this as 0.2, and 2 minus 1 is going to be 0.1. So d is equal to the square root of x sub 2 minus x sub 1. So x sub 2 is minus 4 minus 2 squared plus y sub 2 minus y sub 1. Y sub 2 is 2 minus a negative 1. And I'm going to square that. So the distance is equal to the square root of minus 4 minus 2 is minus 6. So I have a minus 6 squared plus 2 minus minus 1 is 2 plus 1, or 3 squared, which is equal to the square root of minus 6 squared is 36. That's why we did not need to take the absolute values, because whenever you square a number, whether it's a positive number or a negative number, you end up with a positive number. Plus 3 squared, which is 9. So this is equal to the square root of 45. The largest perfect square that goes into 45 is 9. So that's the square root of 9 times the square root of 5. Let's make that look like a 9 and not an A. Okay, so it's the square root of 9 times the square root of 5, which is equal to 3 radical 5. Let me show you some of the mistakes that students often make. Okay, so mistake number 1. So what's the problem here? Well, remember, the distance formula is nothing more than the Pythagorean theorem. A squared plus b squared is equal to c squared. What's the problem here? Well, yes, they added the squares of the two legs, but look what they did. They did not take the difference between the two x values and the two y values. They took the sum. That is a common mistake that students often make. Here's another mistake. Okay, so they found the distance between the x values and the y values, but the problem is they did not apply the Pythagorean theorem. Instead of taking the sum of the squares of the two sides, they took the difference. So the moral of the story is try to learn the distance formula correctly. And that is the distance formula. I hope that helps, and I'll see you next time.